Good evening, everyone, or good morning, wherever it is you are located. It depends on what time you see this video. I am speaking to you from the city of Lynchburg in Virginia. And the purpose of this video is going to be to continue the series on vectors. And we're going to be describing lines. In this video, we're going to be talking about lines and linear dependence, right? We were talking about vectors. You need to watch, if you're not familiar with vectors, you need to watch part one and part two, which I'm linking down below in the description. But I something has happened today, and I am profoundly impacted. I have had a profound impact in my life today for something that's happened. As I started today and I opened up YouTube, we have now surpassed, this channel has now surpassed we now have over 1,000 subscribers. In fact, as of my last count, we have 1,375 subscribers and growing. You have no idea what that means to me and how profoundly shocked I am in a good way. Because if you had known this channel even a month ago, you would have seen that it had, I guess, 165 subscribers, approximately. A lot of them were inactive. Something has happened, and I feel very blessed with what has happened. And I take it as a message from the people who have been subscribing that you're valuing the content. And so I'm going to continue to work for you to produce these videos. And I am so excited about this because that I even decided, I haven't set it up yet, but I am going to give you a mailing address as well because City Tutoring is growing. So I am going to give you a mailing address. I like to receive letters. I often receive letters. I cannot do justice to all the letters I receive, though. Sometimes there was at some point I received hundreds of written letters, correspondence, and I do answer as much as I can. And the correspondence these days, it comes even quicker with the technology that we have. But I do like to practice. I do like to letter write a lot of the time because I feel that many times with the technology that we've got, we've lost sort of that personal connection. So I'm just setting things up and I will be discussing that with you. Also, as I mentioned in another video, there will be new courses offered starting in January 2025. And if you want information on the courses and how to register for them and all that, please email me. You can email us at City Tutoring Maths. I'm going to put that in the description as well. The email I'm still setting up. As I said, I'm very new to the technology. You got to think like the people who know me that they know that this is very new to me. But I want to thank everyone for that. And like I said, I feel very blessed. And I want to answer a question somebody had asked me in another video. They had asked me about where I had studied. I didn't want to get into it in this video, but I realized I neglected to tell you in another video a little bit about my background, my educational background. So I did my undergraduate degree. I did my undergrad for 4 years at Columbia University in the city of New York. And I did pure mathematics there. And then after I finished my undergraduate, I went to the University of London, specifically Imperial College, where I got my master's degree in pure mathematics. I never pursued a doctorate. I didn't feel it was necessary. It has not been necessary in my life. And a lot of people, they have this obsession with titles. Whether they want you to have all these titles, and but it's not necessary. And I kind of followed a very similar path when it comes to degrees as the famous mathematician G.H. Hardy. Now, of course, I don't compare myself to G.H. Hardy. I'm just saying he had a very similar view that I do. He did not have a PhD either. So you don't have to have a PhD to be a mathematician. I'm just responding to some people who have. There was one gentleman. I think it was a gentleman, and I'm using the term very loosely because he seemed very bitter and very rude. And he said, "How dare you call yourself a mathematician?" I can't even remember what video he left that silly comment on. He said, "How dare you?" He said, "Where do you teach? Where do you?" And it just says a lot. Most of the comments are positive, but there's always people who are negative, and I expect that. When you become a public person, and I've been a public person for a long time. I've dealt with different audiences, and you're always going to get trolls. You're always going to get Debbie Downers. You're always going to get people they're just angry at life. And when they leave those comments, by the way, those of you who want to leave negative comments, by all means do so. Thank you for bringing traffic to my channel, by the way. It says a lot about you. Maybe you're in some situation, maybe you're in mom's basement or something, and you have nothing going for you in life, and you want to attack a random person. You don't even know me, but you want to attack me in the comment section. That's fine with me. I enjoy it. I enjoy reading. You think I had someone yesterday, they were writing, I think they were writing from, if I recall correctly, they mentioned they were from South Africa somewhere, and they said something like, "You should delete your channel, get rid of your channel. You're an embarrassment to yourself." I mean, these people are, and I hope that they they realize the irony in what they are saying. But anyway, I feel sorry for them in a way, because I was, growing up and being a Christian, I sometimes have to check myself, and rather than mocking them, and that my natural instinct is to mock them, but at the same time, a lot of those people just need compassion. They are angry individuals. They have not received love in life, and all they do is they emanate hate. They produce hatred because that's all they know. A lot of them are into nihilistic thinking, self-destruction, suicidal thoughts, and that's not going to work, by the way, here at City Tutoring. We are here to share math. I am here to be a positive person. I'm a very happy person in life, by the way, because when you are right, and when you know you are right, the certainty of being right makes it, at least for me, is what gives me happiness. So for those of you who have subscribed and you're interested in mathematics, once again, I do appreciate you. And actually, I am planning on doing a message, like a more general Thanksgiving message to everyone, because you deserve it. And I am doing this for you because I already know the math, but I truly have a passion for sharing math with people, students who struggle with the math. You have no support network, right? You probably don't even have, a lot of your, and I don't want to generalize about teachers or about professors, but you go to a lot of colleges and you're just a number, right? You have a lot of times the tutors are teaching assistants, they're TAs, they're getting paid, for that, but they're not invested in you for a variety of reasons. Then you have a lot of the universities these days, they are research universities, and professors are only interested in research. And they're not really, we need more teaching colleges in America. And that is the passion I have. I have a passion for teaching. Um, and research, of course, is indeed important, but it is not the focus. It is not my focus. It is my focus is to share mathematics, make mathematics have a logical foundation for people, and just continue to grow. So we will be offering. We are located. City Tutoring is here in Lynchburg, but we offer nationwide. I mean, I have students from all over because most of the courses are virtual. I have students all the way from California. I have one student from the UK, and and yes, so I lived in the UK for a very long time. I lived in the UK for a decade or so, more than a decade actually, if I count some months. It's a little bit over a decade, and I was there for my master's degree, and then I worked a little bit in different capacities there. So I spent some time in Europe as well. I spent some time in France. I spent some time in Spain. And then I traveled around. I was in Germany. I traveled to Germany. I didn't live in Germany. And what I learned, a lot of Americans are going and they're leaving the United States, and they're moving out, and they are, emigrating or settling their expats in Europe. And I had a sort of opposite experience. The more time I spent in the European Union, to be specific, the more I valued what America stands for. And I make no apologies for the constitutional values that America has, the constitutional values that are enshrined, for example, in the Bill of Rights. And a lot of people don't value them because you don't have a basis in which to compare. But in my case, when I was able to compare what I saw in Europe, I very much started to value and really identify with and understand the arguments of the American founding fathers, who were very much Eurosceptic in many ways. And so, anyway, I'm not going to get into it in this video, but that's kind of a little bit of background for those of you who asked me about what my educational background was. Most of you have asked it in a good way, but there's always the troll, who they ask because they want to create, they want to stir the pot because they have nothing going in their lives and they don't have a spiritual foundation. And so they just want to leave hateful comments, stupid comments, really. And they're not learning anything. They have no future, basically. The people who hate this channel and the people who have the few individuals, the tiny minority of individuals who have left those silly comments, you have nothing going for you in life. You have no future because the only future is a future of knowledge and the truth, right? Mathematics is about truth. And to paraphrase Jesus Christ, himself, Jesus Christ once said, "The truth will set you free." And that is no less true for mathematics. But anyway, let's dive into the area of vectors and kind of go through the third part of this series. All right, so this video is going to be about lines and linear dependence. We're still talking about vectors in 2 dimensions. Now, you probably remember that in algebra, in your study of algebra, you probably learned that if A, B, and C are constants, then the graph of the equation, let's give you an equation here, AX, the standard form, AX plus BY equals C, and A, B, and C are constants, you probably learned that this is a line. So what we're going to be doing is revisiting the algebra of lines in the Cartesian plane in the context of vectors. Right? And back in the good old days, right, a line wasn't just a random doodle, it was a statement of order. And you see that here with AX plus BY equals C. We learned that this describes a line, something constant, dependable, and really just plain right. Now, we can revisit this hallmark of structure and reason, but we can look at it through the perspective of vectors in the Cartesian plane. And here's the beauty. Any 2 points, you could call them A and B, determine a line. And geometrically, the line consists of A, along with all the points you could reach by moving toward B, or, should the need arise, retreating away from B. And this is really where vectors shine, because they turn the geometry into sort of a pure and unshakable logic, right? And I'm going to give you some examples here, but you know, when we talk about a line, right? And as I said, we have 2 distinct points, A and B. You have a line here, and we could call that AB. And remember the notation we talked about, right? The little arrow that has the ends here. And you can think of the A part, right, as all the points we can reach by going either in the direction of B or in the opposite direction away from B. So that is really what leads us naturally to a description of a line using vectors. And if you need a reminder, you have parametric equations, right? I used to, for some reason, when I was in high school, I used to pronounce it as parametric. I just thought it sounded better, but of course it's not parametric, it's parametric. But I still have, as they say, old habits, right? So if you have a parametric equation, like let's say you had x equals 3t. By the way, I'm assuming you know what again, if you want to watch these videos, I am assuming a certain knowledge. Go by the level you have. If you don't have a pre-calc background, then you're not going to understand what a parametric equation is. So that's why you got to be aware of what level you have. So if you have a parametric equation, like let's say x equals 3t, and the other equation would be y equals 2t. All right, you want to break free from the chaos of slope-intercept forms. And you can sort of rewrite this as xy equals t 3, 2. In other words, can have t and 3, 2. All right, so think about this. Each value of t will give you a point on the line. You have absolute clarity. You have no room here for doubt or compromise, just like math should be. So if we dive into the refined, this sort of refined world of lines and vectors, you're going to see order reigns, and everything is very precise, as it ought to be. After all, right? Why I always say, why settle for shortcuts when you can embrace the elegance of mathematics as it was meant to be? Right? So when we graph a parametric equation, you graph all points such that there is a value of t for which xy is a solution to the equation. Right? So let's start with, I wrote up a little problem that I gave my students who were doing pre-calc last semester, and I'm going to share it with you all. See if it comes up on the screen, because all right, hopefully you can see it here. We're going to explain why AB is the graph of this parametric equation, and then ask ourselves, is this the only parametric equation of the form u plus tb, whose graph is AB? So let's have a look. I have solved these problems, and let's have a look at the graph that you can find from this. I hope it comes up, because I've been having a lot of trouble with the graphics lately. But I did a little graph here for part A. Actually, a student of mine who was very good at using technology did the graph. And so the student shared it with me, and I have his permission. This is the graph, right? AB. Why is this the graph of this parametric equation given to you? Right? So if we work through, this is a classic exercise in lines and linear dependence. There's nothing more satisfying than restoring order to the Cartesian plane. So here we have the points 2, 3. A is 2, 3, of course, as you can see. And B is -3 and 1. And those 2 points determine the line. And we're going to prove with precision why this equation, this parametric equation, is a perfect representation of this line. Now remember, why does the equation work? Remember that a line is nothing more than all the points you can reach by starting at a given point. So here you have A and traveling in the direction of another point B. So the direction from A to B is captured by the vector AB, right? In other words, if you take AB, see if I can write it out. And I usually that smaller arrow, remember we talked about that. We have -3, 1 minus 2, 3. And that's going to give you, well, if you take away -3 minus 2, that's going to give you -5. 1 minus 3 is -2. So you have -5, -2. All right? So what this means is to reach any point, right? You can start at 2, 3, and you add a scaled version of AB. And that is exactly what the parametric equation does. It's clean, it's logical. We can dare say it's perfect. I know that's not a word people enjoy these days, but there is perfection. So you can add to get to any point on AB, you can start from point 2, 3, right? Because A is 2, 3, and you can add some multiple of AB. So AB is the graph of this expression, of this equation. Now for part B, it says, is this the only parametric equation? Is that the only thing, U plus TV, whose graph is this line? Now, of course, the equation we just found here is not the only parametric equation whose graph is AB. You can choose any point on the line as your starting point, and any other point on the line to travel towards or away from to produce an equation for the line. For example, you could start from B and go towards or away from A. Then you have the ray, right? You have you have BA. Right? Let's see if I can write it out again. You have BA equals, you could say negative AB. And this is going to be equal to 5, 2. The opposite, right? So that is why when you think about it, right, you might think that this is the only way to write the line, as we had earlier. But in math, much like life, math allows for some freedom within the bounds of reason, of course, right? If you're not being reasonable, then it makes no sense. But that's why I like math. You could give me some freedom, and you could start at B, like I said, and you can instead of A. So you have a different parametric equation. This time you would have xy negative 3, 1 and plus, let's say, k. Before we even get to that, we should do the 5, 2, right? Because we need the scalar. All right, this is an S, not a 5, by the way, outside the parentheses. I know it looks like a 5, though, but it's just my handwriting. All right, so is this still not unique enough for you? All right, well, let's multiply then the direction vector. The direction vector is 5, 2, by the way. You can multiply it by any non-zero constant. So if I make S, for example, equal 4K, if S equals 4K, then that means you can rewrite your equation as, well, you have negative 3, 1, but you can, if you have 4K, then you have K, 4 times 5 is 20, 4 times 2 is 8. So you have K 28. So what is the bottom line here? U is our starting point. So the U, the starting point, can be any point on the line, and V represents your direction vector. And that can be any non-zero multiple of negative 5, negative 2, right? Let me circle that in red. So any multiple, you see what I'm circling in red? Any multiple of that can work. Math is generous like that. Freedom, but within the confines of its unyielding logic. So there you have it. You've got order, structure, and just enough flexibility to remind you that while math does not compromise its principles, it does reward ingenuity. And as we explore even more ways to bring precision and purpose to the world of vectors. In the next video, we're going to be looking at another problem, which is we're going to be explaining why the graph of the parametric equation, u plus tv, why it fits our geometric description of a line that we described earlier. So there's a lot more problems coming, but I only have time today specifically to do this one. So if this was helpful, please continue to assist me and please continue to subscribe. Those of you who have not subscribed to the channel, I urge you to subscribe. You have seen what has happened. A lot of people have been subscribing because they have seen that I do take this very seriously. They have seen that I don't ask for anything in return. I'm not interested in anything except to share the math. Very few out there are doing these things, and you need to know about these things if you're doing vectors. So thank you, everyone. Thank you for blessing me with your presence. Thank you for being such a positive influence in the comment section. And we are certainly going to be producing more videos as time goes by. Tomorrow, stay tuned for my video for Thanksgiving message tomorrow. And hopefully, a lot of this channel will continue to grow. Thank you and be blessed.